Welcome to the Tall and Urban podcast by the Council on Tall Buildings and Urban Habitat. This is Daniel Safarik. This is Season 1, Timber Rising, sponsored by the USDA Forest Service. We're talking with leading experts about mass timber, a way of building with engineered wood products that is gaining traction around the world. Today we're talking to Mohamad Mohamad, a senior research engineer at Natural Resources Canada in Ottawa. Mohamad, welcome to the podcast.
Thank you.
So we're basically trying to understand what's the value of using mass timber in tall building construction, which is a relatively novel concept for most people. And I think one of the things that we want to spend a little bit of time talking about is understanding that timber's advantage, among timber's many advantages actually, is that it's a high strength to weight ratio, and that might be something that surprises people. I would wonder if you could comment a little bit on that relative to other types of building materials that we use to construct high-rise buildings like steel and concrete.
Absolutely. As you know, in tall buildings, weight is really a major design element because it affects the foundations, foundation design. It does affect the seismic and structural performance. So you are correct in terms of strength to weight ratio. Wood actually has a lot more advantages compared to other conventional structural materials. It's a lot lighter. It's almost 1/4 or less the weight of concrete in that sense. So there are a lot of benefits in terms of foundation savings and the number of stories that you could actually build on the same type of foundation, especially when you have some poor soil conditions underneath the buildings. So that may limit the number of stories that you can actually put on that particular site.
Oh, interesting. Okay. And then in terms of wind and seismic loads being an issue, how does that compare structurally to its counterparts, and what can we do to counteract some of the relative differences?
Well, on the seismic side of things and the wind as well, I mean, we're talking about lateral load, how the building reacts to lateral load being wind or seismic in that sense. Again, the weight of the building is a major element of the seismic design. The type of connection systems that we use in the building, and there are a lot of advanced kind of connection systems that have been developed for use of wood in high-rise applications that would actually help in terms of the seismic and in terms of wind design. But the weight is a major component. So if tall wood buildings are designed properly, they can actually outperform other types of constructions, and definitely they can meet or even exceed the building code, the local building code requirements in any country.
Very interesting. I have heard that most hybrid timber constructions, that is, buildings that use a structural system that is not exclusively timber, but may include some more traditional elements like steel and concrete. In many cases, the application is to put a concrete topping layer on top of the floors in the upper reaches of a tall timber building in order to enhance stability. Is that correct? And are there other hybrid strategies that are useful when constructing tall timber?
Oh, it's true. I mean, it's if you look at the tall wood buildings that have been constructed around the world, in Canada, in the US, in Europe, majority of those are actually using concrete cores as kind of your lateral load resisting system. So using wood diaphragms and shear walls to transfer the loads to the concrete cores, and then the concrete cores will take the load down. But we have to remember that the design of tall wood building is still at its early stage, and there are a lot of those lateral load resisting systems that are being tested. In fact, we see more and more of wood-based lateral load resisting systems that can be used instead of steel and concrete. So I would imagine that with the extensive seismic research that's being conducted at the moment in North America and Europe, there will be less use of concrete, I would say, cores, lateral load resisting systems, and you will see more and more of those resilient like wood-based or mass timber-based shear walls and other systems that can be used, instead. Now, as far as the concrete topping, this is actually to enhance the acoustic and the floor vibration of buildings. I believe, in hybrid buildings, I don't think there's any building that is exclusively made of one particular material. Almost all our buildings are hybrid in one way or the other.
Right.
So I think we need to use the material to its best, be it wood or concrete or steel. Maybe your optimum design, maybe your most cost-effective design actually is a hybrid system. So if that's the case, then let it be. Maybe this is what we should be targeting, is combining all materials in a building to the best of their attributes.
Fantastic. Um, so are there cost savings to be had by using mass timber in high-rise construction from an engineering perspective?
Well, from engineering perspective, again, that comes down to the weight issue of mass timber versus other conventional building materials. There's a lot of savings, associated with the foundation size, and there are also a lot of savings associated with the speed at which you are constructing a wood building, tall wood building versus other materials. I think the UBC Brock Commons 18-story building, they were actually completing 2 stories per week. They were heavy on prefabrication and wood itself, and the mass timber in particular. It lends itself really, really well with prefabrication. So there are a lot of implications, be it on the financial side, be it on the health and safety associated with actually being able to construct your building very quickly. So that wood actually has a lot of advantages in that sense.
So in some sense, it sounds like constructability is where a lot of the advantages come to play, especially when we consider um, the mass production potential of cross-laminated panels, off-site assembly, and then trucking them to the site in a sort of pre-assembled modular condition.
Oh, definitely. As I mentioned, I think mass timber and wood, it really lends itself really, really well with prefabrication. So be it on the panelized sides or be it on the modular side, like I'm talking about volumes where you can stack those kind of similar to shipping containers on top of each other. They are pretty much finished, and the process goes really, really fast. Within a couple of days, you would have your 10-story or 12-story buildings structurally standings, and a lot of finishings would have been done already because they are part of those modules. And there are some new emerging technologies coming up in Canada, in the US, and in Europe, that actually very interesting concepts that allow for modular constructions to be used in tall buildings applications. So I think future is really for panelized and modular construction in mass timber.
It is interesting that at the same time, and I realize these don't come from the same authorities, uh, at the same time that the fire code is sort of predicated on prohibiting certain types of material being used beyond a certain height at present. At the same time, you have governments like British Columbia, which are espousing a timber first construction policy. How do these two initiatives get reconciled with each other?
Yeah, it's definitely a recognition of the importance of forests and wood products, and the need to use your local materials, especially if it's like comes from sustainably managed forests, which is the case in Canada. So it's about going with a material that makes sense, the material that's available out there, it's renewable, and also there's the forest industry in a country like Canada, for example. There are a lot of communities, especially in northern communities, that are dependent on those forest operations. So in a province like BC, as you know, I mean, this province produce a lot of wood. They have a lot of forests, and it is to their advantage to use that, resource in their buildings. So it is, even though it's happening, or it happened at the policy level, it was driven by a lot of interest, in supporting local communities, supporting the economy, and also by research. I mean, there was a lot of research done in BC to demonstrate that actually you can do like mid-rise, and you can do up to 12 stories and even taller with wood without any issues in terms of engineering and design and in terms of performance. So it is really a mix. It's a policy plus economy plus also engineering as well. I mean, people understand the environmental benefits of using wood in construction, and that was another major driver in BC and in other provinces in Canada in terms of climate change and using wood as a green building material to mitigate climate change.
Well, thank you so much for spending the time with me today. That's been really informative.
That's great. Thank you.